All right, so I want to review quick before we talk about our last thing, which is how useful these lines are for making predictions. So R is our correlation coefficient. That's the measure of the strength and direction of the linear relationship we're seeing between the two variables. R squared is the new thing that we're introducing. This is the coefficient of determination. And it does two things, although they kind of really go hand in hand. The first is that it describes the percent variation in Y that is explained by the model, as well as how useful the line will be in making predictions. All right, so this coefficient of determination in this issue of the percent variation is kind of a really nebulous and complex idea. But the simplest way I can maybe kind of explain that is that it is the amount of variability of one factor that's caused by its relationship to the other factor. Okay, so it's relating how those two variables go together. Okay, but what it means in practical terms for you is that if R squared is close to 0, it means your line is probably not going to give you very good predictions. And if your R squared value is close to 1, it's going to give you pretty good predictions as long as you're using it responsibly. Okay, so R squared values range from 0 to 1, 0 being not such a great predictor, 1 being a pretty good predictor. Okay, the other issue with predictions is something called extrapolation. Okay, and so extrapolation would be using your line to make predictions way outside of where your data points are. So if you think about if we were to plot the number of people that are in space each year, and I made a scatter plot of that, and I could fit a line. We probably went to space, I don't know, in the 1960s maybe, up through 2020. Now, I could use that line to make some predictions. Maybe I could predict the number of people we expect are going to be in space in the year 2025. That's probably okay. Where it's going to be a problem, though, and where you would run into the issue of extrapolation is if I tried to use this equation to predict how many people we're going to expect to see in space in the year 2300. Okay, so that's a long ways away. Many things could change between now and then. So using that line to predict a value 100 years from now into the future, or even if I use it to predict 50 years into the past, it's not going to be useful. It's going to give me basically trash back out of the equation. So that's what extrapolation is. It's using that equation to make a prediction really way outside of what's appropriate for where your data is sitting at. And when we looked at that manatee one, remember we thought that that looked really good. And we got an R squared value on our classwork of 0.9091. So about 90%. So that's super close to 1. And so we would say if we were using that equation to make predictions about how many manatees we would expect to die based on the number of boats in the water, this would provide us with a pretty good prediction, pretty good estimate, as long as we're just not using it in a way that would give us extrapolation.